one dimension, and now you have your screw made. You don't have to go through this every single time. So as you create screws, say you do the 1/4 20, you do a 5/16 24, you do all these other screws, save them into some sort of working directory. Okay? You can do the same thing for washers, so on and so forth, so that you don't have to recreate everything all the time. Okay? Make your own directories up. All right, so the next thing I want to do is the helical sweep. Under here, under sweeps, click on here, it's got a sweep and a helical sweep. Okay? The one down here has got the blend and rotational blend. Okay? But this is where you're going to start up in here. We want a helical sweep. Okay? When you do the screws for the Stirling engine, okay, do not do the helical sweep. Okay? It takes a lot of memory and a lot of calculation to go ahead and create that rotation going up in the helical. Okay? When you do your capstone project, you will have to do at least one helical sweep. Okay? So come in here. Okay. So under the references here, sweep profile. You want to define it. So you have to pick the plane where it's going to go onto it. So I'm going to use this plane here. And I will hit sketch. In this case, I'm going to flip it up. Okay. I want a center line because it needs to go around something. I'm also going to add in a reference. I'm going to pick up this edge right here. The reason I'm using a new reference is just to make it easy to snap things to. Otherwise, I'd have to force dimensions in. It just makes it a little bit quicker when I do this. The profile basically is what direction is it going to go. So what I'm going to do is take a line, let it snap to that point right here, and I'm going to bring it down to about here. I know that my pitch is going to be 0.05. So this value here, I want to put in at 1.95 or less. Okay? The reason I do this, and it doesn't seem to be an issue as much with the Creo that we've been using, but the older versions of this, if this number, say I went all the way to 2, okay, and I was trying to remove material, once it got outside of this part, it would fail to regenerate. So always leave it at least one pitch short. Okay? That's the reason for that. So it could be 0.19, that's fine also. So this gives me the direction that it's going. I've got my center line, and it's going to work in this direction. So from here down. So I hit the check mark for OK. Okay? This number here is your pitch. The same one is showing here. I'm not going to change it yet. You can and probably should, but I'm not going to do it yet. This is your right-handed thread. That's left-handed. Okay? Most of the time, 99.9% of the time, you're going to have right-handed threads. Okay? The places where you see left-handed threads is in power transmission devices where it has a nut on it, such that the driving force tightens that nut down even more, rather than loosening it back up. Okay? But most of the time, you're going to see right-handed threads. Okay? Things like turnbuckles, okay, where you take a center section and you rotate that center section, it'll have a right and left-handed thread so it can open and close the sides together. Okay. So on here, this is create the sweep. Okay. So we click on that one. You notice it added in this line and this line. Okay. What this is, that gives me the center point, or the point that it's going to start that sweep from. So I'm going to take the line tool, snap it to here. I'm just drawing a triangle. Click off of it. Now I'm going to zoom in. Again, we know this angle is going to be 60 degrees. This angle, which is going to be half of that, will be 30 degrees. This dimension is not the pitch. Okay? That dimension will be half of the pitch. The dimension from here to here is the pitch. Okay? It doesn't matter which one you put in. I can put this in at 0.2 or 0.025, or I can force in my dimension for the pitch and put in 0.05. I'll just use 0.025 for here. Okay? So your shape is drawn out. You've got the direction that it's going. It's going to go down. You've got your center line already in there. When I hit the check mark, up here. I want to remove material here. Now it looks kind of odd. Okay? That's because the pitch isn't set up correctly. The pitch right now is 4 times what I want that pitch to be. Okay? So where it says 0.2 or 0.2 up top, go ahead and you change that. Now, this is right-handed. Okay? I'm going down, so it's going this way. Right-handed, just like if you were turning the screw in. Your left-handed would look like this, going the opposite direction. That's all you have to do to change it, from right to left. Okay? Change the pitch, 0.05, and now it looks a lot more like a screw. So with that point, I'm going to accept it. So that's your basic helical sweep. Okay? Now, in order to go ahead and create the rest of this, okay, what I want to do, and you got to have a little bit of a strategy involved here, is if you notice on the screws here, the thread here goes all the way up to the bottom of that head. Okay? If I go ahead and extrude the head onto this surface here and go up, I won't have a completed thread here. So when I extrude the head onto here, I'm going to do from that surface and I'm going to go down into the threaded section, and that way it absorbs this area where it's not complete. Okay? So the next thing I'm going to do is extrude on top of this surface. Okay? I've got my datum turned off, but that's all right. It's going to be a circle. 0.375 in diameter. Check mark. Split my direction. And 0.244. Okay? If you look these numbers up, it'll tell you that the head will be between 0.24 and 0.244 in depth. Okay? That's why on your base plate, when we did the counter bores on it, okay, for the bottom of the base plate, they were 1/4 inch deep. That way the entire head would fit up inside of that hole. Okay? So now we've got that done. Okay? Now, the next thing we want to do is we're going to put this little section in right here. Okay? All that is a hexagon shape. There's a couple different ways you can do it. You can go in under the extrusion, you can use a pallet. Okay? We're going to place it here. Okay? It's got the pallet. I'm not going to use the pallet. Okay? I'm going to do something a little more useful. But if you want to play with the pallet, it's got different shapes and forms and things like that. If you ever get into, say you decide you don't like mechanical engineering and you get into civil engineering, they'll have channel forms and things like that that you can get and use that also later on. Okay? But I'm not going to do it that way. I'm going to do something a little more useful to give you an idea how you can create most anything that you want. Okay? So I've got my center point here, got my 2 references. Okay? I need to draw a hexagon shape. Okay? Just freehanding a hexagon shape is going to take you a good hour probably to get it set up correctly. Okay? So you need to be creative. You've used Inventor. Who's used AutoCAD? Okay? They use a lot of construction lines. They use the layers. You set one layer up for construction lines, right? Well, you can use construction lines here too. But what we're going to do, instead of going into construction mode, we're just going to use this center line here. And we're going to use it as a construction line.
Are construction lines where you can like merge shapes into each other?
Now the construction line actually sets up sort of a line or something that you can use to snap to. Okay? A lot of times when you're using, say, AutoCAD, it's done in layers. And depending on what kind of feature you're doing, one layer has one color, one layer has another, constructions will have another. Well, you can turn those layers off when you're done. Okay? But you can use them for snapping too and dimensioning, things like that. We're kind of doing this the same way, except we won't really turn layers on and off. The construction line just won't show up when we're done. So I use the center line here. And I'll let it snap to the center point, and I'll come off to the side here. Center point here to here. Okay? On a hexagon, it's got 6 surfaces, right? Okay? So to figure out what these angles need to be, you take 360 divide it by how many surfaces you have, and that'll give you the answer. So it's going to be 60 degrees for every section. Okay? And it works that way for any type of pentagon, or not pentagon, hexagon, pentagon, all of them. Okay, squares, same thing. Okay? When it crosses, you get 90 degrees, 360 by 490. Okay, just geometry. So all these get set at 60. Okay? Then you're going to take a line, snap it to that point, and you're going to use the constraints on here. The H is horizontal. Okay? Snap there. Snap to this line, come across till the parallel line shows up. What that's telling me now is that this line and this line are parallel. So now I click on that one. And then you use these constraints all the way around. So you're making use of the features that Pro-E has in it. So now I've got my shape. Now it's giving me this dimension. Okay? I don't know that dimension. Okay? And I don't want to do the calculation to get it. Okay? Dimension I do know is that I'm going to use a 3/16 okay, Allen wrench, which is a hexagon shaped wrench, to drive this. Okay? So I know that from here to here is 3/16 of an inch. So I'm going to force that dimension in. So you use, under the dimension here, you use normal, click on this line and that line, and then center mouse off to the side. 0.1875 is 3/16 of an inch. So I force that in. Okay, I hit my check mark. Now if I roll this around, it's going the wrong way. So I flip this over. Okay, it's going to remove material for me. My depth on here is going to be about 0.15.